Constant velocity occurs when an object is moving along a straight line, and every second the object moves, it travels the same amount of meters.
Which basically means the velocity does not change with time.
Go! Acceleration is the rate of change of velocity per unit of time.
You calculate acceleration by taking the final velocity minus the initial velocity, and then divide that by the time.
I ran a distance of 10.97 meters, and my initial velocity was calculated out to be 2.1 meters per second. I ended at a stop, so my final velocity is 0 meters per second. I ran for a total time of 5.25 seconds. So this is all my given information, and the acceleration formula is Vf minus Vi divided by t. So you would do 0 minus 2.1 divided by 5.25, and you would get an acceleration of negative 0.4 meters per second squared. But since you can't have a negative acceleration, you would just ignore the negative sign, and your acceleration would be 0.4 meters per second squared.
An object in free fall is an example of something accelerating.
As an object free falls, it accelerates as it falls. So each second it falls, its velocity increases. The initial velocity of the marker was 0 meters per second since it started at rest, and the acceleration of the marker was negative 9.8 meters per second because of gravity. The time the marker was falling was 0.71 seconds. So this is your given, and you're missing your final velocity. So to find the final velocity of this free fall problem, you would use the formula Vf equals Vi plus acceleration times time. So you would do this, and then you would get negative 6.7, and you would exclude the negative, and you would get 6.7 meters per second as your final velocity. Scalar is the measurement of just magnitude. Vector is the measurement of both magnitude and direction. Some examples of scalar quantities are time, speed, temperature, and volume.
The reason these are scalar is because they only describe magnitude. Some examples of vector quantities are velocity, acceleration, and displacement. The reason these are vectors is because they both describe magnitude and direction. Precision refers to how close two or more measurements are to each other.
Accuracy refers to how close two or more measurements are to the standard or known value. For this one, it's a dartboard, and they're all on the red center, but for this one, they're not on the red center, so they're not correct, but they're all close together, so it's precision.
Newton's first law states that an object in motion stays in motion, and an object at rest stays at rest unless acted upon by an outside force. They are also known as the laws of inertia. Inertia refers to an object's resistance to change in motion.
Newton's second law states that acceleration is produced when a force acts on a mass. The greater the mass of the object, the greater amount of force needed to accelerate the object.
So the heavier the object is, the more force you need to make it move the same distance as a lighter object.
The book weighs 0.9 newtons, so to find the mass, I divided 0.9 by negative 9.8, the acceleration, to get a mass of 0.1 kilograms. The acceleration is negative 9.8 meters per second squared because we pushed the book down, so gravity took over. So now to find the force, or Fnet, we would use Fnet equals mass times acceleration. And we know mass equals 0.1 kilograms and acceleration equals negative 9.8 meters per second squared. So we would just plug it in and you would get Fnet equals 0.1 times negative 9.8. So your Fnet would be negative 0.98. Ignore the negative and your Fnet is 0.98 newtons. Newton's third law states that for every action, there is an equal and opposite reaction. Example being punching the wall.
So for every force, there is a reaction force that is equal in size, but opposite in direction.
Mass is the amount of matter an object has and is a measure of inertia. Mass is measured in the unit of kilograms. So for example, the amount of stuffing inside of the shark, it makes up the shark, so it's basically like the matter inside of us.
Weight is the gravitational pull on mass. Weight is also a force. Weight is measured in the unit newtons. So, I'm sorry, thanks. So like the scale, as you see here, I'm going to weigh my stool. Got it from IKEA. I want to zoom in here. It weighs 6 pounds, so that is its weight, not its mass, because that's its gravitational pull.
Whoa!
The different types of forces include frictional, tension, normal, air resistance, applied, and gravitational.
Frictional force is a force that opposes motion. So I'm the frictional force and she's the applied.
Tension force is a force that is created by a rope or any type of string that is pulled tight from forces on opposite ends. For example, bag on strap.
Normal force is a force that holds up the weight of an object. Like us sitting on the ground, that's why we're not falling through the floor right now, because of normal force.
True.
Air resistance is a force that opposes gravity.
Applied force is a force that a person or object applies to another object.
Gravitational force is the force that pulls you to the center of the earth.
Okay.
Physics!
I just love physics. Okay, we're good.